Welcome back to Hypothesis Testing Done Right, Part 8 of 14. In Part 7, we fixed where the rejection region sits, one-sided versus two-sided. Now we move from a yes or no verdict to a continuous measure of surprise, the p-value, and we nail down its definition in exactly the form you must memorize. Then connect it back to the critical value. Critical values give a yes or no verdict at a fixed alpha. The p-value reports something richer, how extreme the data are, on a continuous scale. Here is the definition, and it must be memorized in exactly this form. The p-value is the probability, computed, assuming the null hypothesis is true, of observing a test statistic at least as extreme as the one you actually got. Read it slowly. Everything is conditioned on the null being true. We live inside the skeptic's world where mu is 0, and ask, in that world, how often would noise alone hand me a result this striking, or more so? A small p-value means this data would be a real surprise if the null were true. Evidence against the null. For Sam's one-sided test, the p-value is the area in the upper tail of the t-distribution beyond 1.69, which works out to about 0.046. Since that is below 0.05, Sam rejects the null at the 5% level, the same verdict the critical value gave. That is no accident. The p-value is below alpha, exactly when the statistic is past the critical value. They are two views of one comparison. For a two-sided test, you double the one-tail area, so a statistic of 1.96 gives a two-sided p of about 0.05. Let's make sure the logic of that definition is fully clear, because the next part hinges on it. A critical value gives you a single binary verdict at a fixed significance level. Past the line, reject; short of it, do not. The p-value upgrades that to a continuous scale. It tells you not just whether you crossed the line, but how far past it you are, measured as a probability. And the crucial thing is where the calculation lives. The entire computation takes place inside the skeptic's world, where the null is assumed true and mu is exactly 0. We never step outside that world to ask whether it is the right one. We simply ask, if the null really held, how often would random noise alone hand me a result at least this striking? That framing has a consequence worth stating out loud. In the p-value, the hypothesis is treated as fixed, assumed, not questioned. And the data are the random thing whose extremeness we are measuring. Keep that orientation firmly in mind, because in the next part, we will see that flipping it is the most common and most damaging error in all of applied statistics. To summarize Part 8, the p-value is the probability, computed assuming the null hypothesis is true, of observing a test statistic at least as extreme as the one you actually got. It is a continuous measure of surprise that upgrades the binary critical value verdict, and the two always agree. The p-value falls below alpha exactly when the statistic clears the cutoff. For Sam, the p-value is about 0.046, just past the 5% bar. The orientation to hold on to is that everything is computed inside the skeptic's world, where the null is assumed and the data are the random thing whose extremeness we measure. In Part 9, we confront what happens when people flip that orientation, the correction that matters more than almost anything else in this book.